Okay, so in this video, we're going to do some examples of VA, HA, and POD, and even, odd, or neither. So first, we're going to take some equations, and we're going to determine if they have a vertical asymptote, so a VA, a horizontal asymptote, or a POD. Okay, so remember, in order to determine the VA and POD, I have to factor. However, HA I can figure out first, so I can do little over big, big over little, or same over same, and this is definitely little over big. So little over big has a horizontal asymptote at y equals 0 every time. So to find vertical and POD, I know there's no chance of having a POD. Why do I know that? Well, I know that because there's no factor of x in the numerator, so there's nothing that can cross out. So there's no chance of having a POD. So let's just figure out what our vertical asymptotes are. So the first thing I need to do is factor out a GCF of 3. That'll just make my life a lot easier. So I have 1 over 3 times x plus 3, x minus 2. To find my VA, I set those two factors equal to 0. So I have x plus 3 is 0. X minus 2 is 0, so I have vertical asymptotes at -3 and +2. So again, VA, HA, and POD. So I'm always going to go for VA first because I can tell immediately what I have. So this is big over little, which means that my HA is undefined. So in order to figure out if I have a VA or POD, I need to factor. So I'm going to take a GCF of an x out of the numerator. And then I'm going to take a GCF of a -3 out of the denominator. And I like to do that because I like my x squared term to be positive. So once I've done that, now I have those two trinomials that I can factor. And I have x times x minus 3, x plus 2, all over -3 times x plus 3, x minus 2. Okay, so these are just opposite of each other. So again, I have no POD, but these two will make up my vertical asymptotes. So I have a vertical asymptote at -3 and +2. Okay, so again, VA, HA, and POD. Okay, so again, I immediately know that I have no POD because there's no factor of x in the numerator. My HA, this is little over big, so my horizontal asymptote is y equals 0. So to figure out what my VAs are, I need to factor. So I have x minus 3. So I have two VAs. X is equal to 0, and x minus 3 is equal to 0. So my two vertical asymptotes, x equals 0 and x equals +3. Okay, so VA, HA, and POD. So I do have a chance for a POD, so I'm going to have to factor. But my HA is big over little, so this is going to be undefined. So I need to factor. So I'm going to factor out an x first. That gives me x squared minus 9. Factor out a 3. And then I need to factor again. Okay. So, do I have a POD? The answer is yes, because these two factors right here are going to cancel out. And that gives me a POD. So I set it equal to 0 just like I do for the VA, and I get that x is equal to 3. So I have a point of discontinuity at x is equal to 3. I have one remaining factor in the denominator. So I'm going to set it equal to 0, and that is going to give me my my vertical asymptote. So again, VA, HA, and POD. Okay, so HA, I have same over same, so my coefficients of these two terms would be 1 over a negative 4. So that means that my HA is y is equal to a negative 1/4. So in order to find my VA and my POD, I have to factor. So I'm going to factor out a GCF of a negative 4 first. So then I have x plus 3, x minus 2, okay? So then the question becomes, do I have a POD? And I do here. And then I still have this term that will be a vertical asymptote. So we have a POD at x plus 3 is equal to 0. So x is equal to negative 3. And a vertical asymptote at x plus 1 is equal to 0. So x is equal to negative 1. So the next topic we'll talk about is even, odd, or neither. So remember that when we are algebraically trying to determine if something is even, odd, or neither, we're talking about symmetry here, and we're going to plug in a negative x. Okay, if you plug in a negative x and get the exact same thing, then it is even. If you get the exact opposite, meaning every single sign changes, that is odd. And if it does neither one of those things, then it's neither, right? Okay, so we're going to plug in our negative x. So I have f of negative x is equal to negative 2 times negative x cubed plus 5 times negative x. So you have negative 2 times negative x cubed is a negative x, which will make, so that gives me negative 2 times negative x. And 5 times a negative x is negative 5x. So a negative times a negative, so a negative 2 times a negative x is a positive 2x minus 5x. Okay, so we're going to look. 2x in this term is, in my negative x equation, is positive. It's negative here, so this should be cubed, sorry. And my 5x term is negative, and it's positive in the original, which makes this even, odd, or neither. Which one? It's definitely odd. Okay, so we have the next one. So algebraically, we plug in a negative x. So I have a negative x quantity squared plus 1 over the absolute value of negative x. So a negative x squared is a positive plus 1. The constant doesn't change. The absolute value of x and the absolute value of negative x are exactly the same. So it gives me this. And if you notice, this and this are identical, which means this is even. Okay, so again, we're going to plug in that negative x. So I have f of negative x is equal to negative x to the 4th over negative x to the 3rd minus 1. So a negative to a 4th power is a positive. A negative to an odd power is a negative. And what do we have? Well, need to think about this one. Okay, so this is the only one that changed. Okay, so we know for a fact that it's not even, but how can we know whether it is odd or neither? Okay, so a single term can be odd, but does this sign change right here affect the sign of the entire term? And it doesn't. It only affects the sign of what's in green, which means that this is neither. And our last one, we're going to plug in a negative x. So I have negative x quantity squared plus negative x minus 3. So a negative squared is a positive. A negative is just a negative minus 3. Even, odd, or neither. So we have the same, but then this one is opposite, and this one is same, but that doesn't matter because we already know that it's neither.